Hello, everyone. Okay, so today we are talking about writing the equations of parallel lines and perpendicular lines. So you know there's two ways that we've learned to write an equation of a line. One is point-slope form. This is when you have a point and a slope. So it looks like this, y minus y1 equals m times x minus x1, right? There's our point, x1, y1, and there's our slope, m. Okay, and then we also have slope-intercept form. That's our y equals mx plus b form, right? Because there's our slope and there's our y-intercept, okay? So if I have a question like this and it says, write an equation of a line that passes through this point here, this will be my x1, y1, and is parallel to this. Well, we know to write an equation, we need a point and a slope. Well, we've got a point. Here's our point, x1, y1. Well, now we need a slope. So what is the parallel slope to this line? Well, parallel slope is same slope, so I'm going to keep the same slope of 3. So now just to write the equation, I can plug in x1, y1. I can plug in 3, right? The x and the y just kind of hang out where they are. And there it is. I'm done. It's already in point-slope form, right? Now, if they ask for the same type of thing, but this time for slope-intercept form, well, then we would have to solve for y, because that means they want y by itself. They want it in this y equals mx plus b form. All right, so this one we will do in slope-intercept form, so we will kind of solve it all the way out. But in addition, this one they want to be perpendicular. Okay, so not the same slope this time. We would take the point, here's our point, x1, y1, but instead of doing the same slope like you would for a parallel line, for a perpendicular line, you would do opposite reciprocal, right? So this is my opposite reciprocal slope. So I'm going to use x1, y1 and my opposite reciprocal slope, and I'm still going to use this equation to plug it in, right? Because I've already got I've already got a point, right? So I'm still going to use this equation. I'm going to plug in my point, 2, 5. We're going to plug that in there. And then we're going to plug in our perpendicular slope here, okay? And that is my point slope form. So now to write it in slope-intercept form, I need to solve for y. So we'll get rid of the parentheses by distributing through here. So that'll be negative 3/2 x, and then negative times negative will be positive 6/2, right? Because that's like 2 over 1. So 6 over 2, which is the same as 3. And then I can add the 5 over to the other side so that I get y by itself. And I'll get y equals negative 3/2 x, and then 3 plus 5 is 8. So there is my slope-intercept form of the perpendicular equation. Okay, so that's how we would write the equation of a line parallel or perpendicular to another line through a particular point. So anytime they give you a point, think point-slope form first, and then if they ask for slope-intercept form, you can go ahead and solve for y. All right, so let's look at this one. They give us a line, they give us a point, and they want parallel, okay? Well, obviously the point is going to be our x1, y1, right? And then they want it parallel to this line. So pick out the slope, y equals mx plus b. Here's my slope. And for parallel lines, I need the same slope. So I'm going to use the same slope with this point in my point slope form. That'll give me the equation of the line. Now this one, it actually asks for point slope form. So once I get it plugged in there, I'm just done. I don't have to solve for y. So let's go ahead and plug it in here. So y minus y1 equals m. My slope is going to be negative 3 because I'm not going to change the slope, times x minus x1. And of course, minus a negative 2 would change to a plus 2. And like I said, if they ask for point slope form, well, that's what I've got. I don't even have to do anything else to it. I'm done, right? Okay, now this one, they give me the line, they give me the point, but they ask for slope-intercept form. Well, I don't have an intercept. Slope-intercept is y equals mx plus b. I don't have an intercept, I have a point. So I'm actually going to use point-slope form again. with my x1, y1 for my point. But then I'm just going to have to go a little bit further and solve for y so that it's in this format of y equals mx plus b. Okay, so first of all, I want to go perpendicular this time. So find your slope, y equals mx plus b, and then take the perpendicular slope. Since that's 5 over 1, the perpendicular would be negative 1 over 5, right? Opposite sign and reciprocal. And then I'm going to plug both of these into my point slope form. So let's see, y minus y1 equals m times x minus x1. Okay, so you can see here's my equation of a line, but they specifically wanted slope-intercept form. So I'm going to have to actually keep going and solve for y. So distribute, get rid of the parentheses, get y by itself. So let's see, this will be negative 1/5 x. Negative times negative is positive. This is really 5 over 5, right? 1 times 5 over 5 times 1. So 5 over 5 is really 1. And then I can add 9 to the other side so that I get it all on the same side of the equation. Y equals negative 1/5 x plus 10. And there is my slope-intercept form. Slope-intercept, slope-y-intercept, right? Okay. Now, this is a little bit different because this one says parallel to the y-axis. So you think, okay, well, what is my slope if it's parallel to the y-axis? Well, the y-axis goes this way, right? So if it's parallel to the y-axis, it's going to be a vertical line. Vertical line vux, right? So that means that the slope is going to be undefined. So it's like, wait a second, how am I going to write y equals mx plus b and plug in an undefined? You can't. This is kind of that weird format. If it's a vertical line with an undefined slope, then it's always going to be an x equals equation. Well, x equals what? What do you want x to equal? Well, I want it to go through this point. So isn't x going to have to be negative 1? Yeah. So that is the equation of the line parallel to the y-axis passing through this point. And if you don't believe it, get a piece of graph paper and graph it out. If I were to graph this point, negative 1, 17, way up here, and I were to draw a line parallel to the y-axis through that point, think about what that equation is. It would be a vertical line, so it would be vux. It would be crossing the x-axis at negative 1. So this is the equation, x equals negative 1. So if you want to draw it out, if that helps, then you can do that. If not, you can just think, okay, well, vertical line has to be an x equals equation, and for this point to be on that line, x is going to have to be negative 1. Okay, let's look at this one, perpendicular to the x-axis. Well, I know the x-axis goes like this, right? And if I want perpendicular to the x-axis, then I want to go like this, right? So parallel to the x-axis, that would have been a Hoy line, but we want perpendicular to the x-axis, so that is going to be another Vux line, right? So it's going to be another x equals equation with an undefined slope, and in order to go through this point, what is x going to have to equal? Negative 12, right? Now, if it had said parallel to the x-axis, well, then it would have been a Hoy equation, and it would have been y equals negative 2, because, you know, your y equals equations are horizontal lines. Okay, but this one was perpendicular, so it was another x equals equation.